Hey everyone.
It's live.
It's like old times. Hey everyone.
It's live.
It's like old times.
Ross, are you smiling because it's just stuck on you, the video now?
Hey everyone. I think there are like 30 people in a room and no one's saying a word. Hey Alex, hey.
I'm good, thank you.
Guys.
I was just thinking, it's like old times. It's like all these familiar faces.
It's great to see you all.
Yeah.
It's been what, like more than a really long time doing this.
We haven't had this.
Cool.
Yeah. Ross, is that your plan to win the hackathon at the back?
It's my plan. It's the... Yeah, I don't know what it is. There's a whole lot of plans on there.
It's this big list of to-dos that Shelley left for him.
Yeah. Actually, that started to happen, right? It's the other way around now. She's like coming in here all the time telling me what I need to do. It's funny how the time goes, hey? It's like it's only been a few months, but it feels like we've been working together for years. It's bizarre.
Yeah.
It's energy.
Don't know why it's like that. Maybe it's because you work 24/7.
What's up, guys and girls?
Hey.
Hey, Kevin.
Hey, Kevin.
I see we've got Bart on the call. We've got Matt W. from Block.One. Trying to see if there's anyone else Block.One that joined in. Seems to be it. I think we'll give it about two more minutes. I still see some people adding to the call, and then we'll get started.
Hey, Rob, did you set up the live stream? Cool, thank you.
No problem. I'll provide the link.
There are people in the channels also asking for the Zoom link.
Eve, which channel are you talking about?
I'm talking about, hold on, I'm on my mobile, so I think it was in Block Rose. It's Roger Davies from EOS UK. Are we sharing that out? I would imagine that we are.
I think we should try and not put it into like a 4,000 person channel.
Jim from EOS UK is on this.
Yeah.
So
okay, well then we're good.
I don't quite know why he's not got it. I managed to find it. It'll be here in a minute. I've posted it to Jim as well, so he'll find us.
Awesome. Thank you, Jim.
Eves, are you on a bus or a train?
That's his limo.
Yeah, that's my limo because EOS Nation is so filthy rich like that. I'm on a train on my way to Toronto. I'm speaking at an event tonight.
You're always on the move, I think.
I'm pretty much living in some type of form of transportation at some point, yes. And on that, I'll see you all in London. Whoever's showing up, I'll be in London in 2 weeks.
Yeah, no, wonderful.
Hey, did anyone read the article that said block producers are making between like $3 and $30 million a year?
That would be wonderful.
I think,
that's not the case for me.
I would love to read that article.
I think Eve is the one who wrote that.
Yeah, yeah. At current valuation, that's a lot.
You're chopping, Eve.
Yeah, I like how they always keep referencing the $10,000 a day. Like, since when? And when is this? How does this? And who's currently making $10,000 a day? I'd like to meet those people.
I believe that was a Reddit thread, and now it has not died.
All right, I think we're probably good to start now. About 52 people here. So a couple things we want to touch on this morning, or night, wherever you are. Two main things would be greylisting and all things around that. So, what are the issues surrounding greylisting? What's a more viable solution? What, if anything, should we be talking about in creating a more permanent solution? And what Block.One has already worked through or thought of and said, hey, this is a good idea or not a good idea based on their understanding. Another thing would be the updates, 1.2.3, 1.2.4, and the patch last night, 1.2.5. See what, if anything, people are seeing, and just giving, I guess, Block.One Bart some feedback on that since they requested it. I think we should probably start. I think the more pressing matter is the memory leak going on with the new updates. So it's tied into greylisting, of course. But if anyone wants to get started with some feedback on 1.2.4, 1.2.5, and what their nodes are seeing, could be a good place to start, I think.
I guess just a quick question on that is that it's my understanding at the moment that the memory leak is kind of interlinked with the CPU problem, because from my perspective, and I may be wrong here, but I see the CPU problem as a bigger problem than the memory leak. And neither is good. Don't get me wrong, but if the leak is understood to be a leading factor to the CPU problem, then then we should certainly give it priority. But to me, I'm not sure how everyone else feels, but the CPU issue seems to be a bigger problem.
Yeah, as far as I've seen, they are pretty linked, because whenever one of my nodes is leaking memory, the CPU goes to 100%. It keeps like that. So I woke up this morning, 2 nodes were completely locked up, and then the latency of the block propagation starts adding up, and then we have to reset, and memory goes down again. It's like the memory is usually 1.7 gigs of resident memory, and then goes to 35 gigs for a peer node only, no plugins. So it's pretty weird.
Okay, all right. So they are definitely interlinked then.
Yeah.
Are there perf traces somewhere? Anyone who took profiling information from those running nodes?
No, I didn't.
But I actually, I may just be the monkey that's going to ask the dumb question, but I don't actually know how what the best way to take perf information like that would be. I mean, normally you would need debug symbols, on a box to do something like that, wouldn't you?
The standard build allows you to give pretty solid information depending where you're running. I don't know if you're running in Docker. We had also a solution for.
Yeah, we built a fairly easy to use recipe for Docker, but not just for Docker, but
And as the release builds that Block.One puts out, they actually have the debug the symbols, but even though they're not in debug, like release with symbols.
Oh, okay. So I guess is there instructions anywhere on kind of like if you wanted to actually take perf information to share?
Yeah, just reach out to our Stefan from EOS Canada. He's the master of all this profile and stuff.
All right, cool.
I set up a script on our node so we can run it, but yeah, this morning we had these issues and we actually restarted the node to fix the issue before we run the perf, so we messed up on that. Next time we're going to call it, but let me know. I have pretty clear instructions on how to get the debug symbols right.
So from Block.One's perspective, the past 3 patch releases, so that would be 1.2.3, 1.2.4, 1.2.5, have all had wildly different memory footprints. And of course, we've addressed at least one memory leak in this latest patch. I'm not willing to commit to say that we fixed all the leaks. That leak would have had a pretty severe CPU penalty associated with it in certain circumstances. So when we are talking about this on this call, it would be helpful, at least from my perspective, if we would kind of caveat each of the kind of sweeping statements we're making about which version you're observing it on, or if it's kind of an observation that straddles versions, so that we can kind of determine which issues we might have already started to address with the bug fixes we put in, and which are still outstanding and probably undiscovered. At this point, we're a little thin on theories for where additional leaks and CPU load can be coming from with the newest patch. So we'd be looking to discover bugs if it's 1.2.5. We'd be looking to see if we fixed a major bug if your issue is mostly representing 1.2.3 or 1.4. And the biggest difference between 1.2.3 and 1.2.4, just to clear the air, is memory pinning, automatic memory pinning of the state database, which would, from the outside, appear as those nodes starting up with an instant load of whatever you set your shared memory file size to. So if you've got 64 gigs of or more in your shared memory file, you would see a pretty large physical commitment in 1.2.4 that you did not see in 1.2.3 or in 1.2.5 because we backed out on that functional change. It was doing a lot.
So maybe we could steer that conversation in that direction. I know there's been some people not releasing. Our producer is still running on 1.1.6, and so there's been some issues that are otherwise generally, I don't know what, some other issues that have been pulling us back from going to 1.2.x. So are there any other issues people want to discuss now that we could address so that eventually we move to 1.2, everyone? Nice office, by the way, Bart. That's new stuff, huh? Wow.
Yeah, this is our new office behind us. We're renovating most of this building to fit our offices as well.
For reference, Bart, I have 1.2.5 running on a peer node with around 300 peers, and it is currently pinned at 100% CPU, and I believe it's leaking memory. Comparatively to another node that only has like 5 peers, it has like 1.8 gigs. This one has 2.6 right now, and this was restarted last night with the patch. So I think it's leaking slower, but it still seems to be leaking.
Okay, so we've still got a target out there. Are you in a situation where, as Alexander has suggested, you can take a perf capture of that?
Yeah, I can do that after this call.
Yeah, if you're willing to share that information with us, that will certainly help us locate at least the CPU side of that load fast. And usually they're pretty coupled. If something's being abused, it's a growing buffer, and it's when the end of your login scaling gets too big.
Yeah, happy to do that.
This may be and I don't mean this to come off as obnoxious, but is there any way that we can get you guys to run a node that's peered into the network as well? I mean, it seems like this kind of capture information is something that
I'm not going to say that we don't have any nodes in the peer-to-peer network right now. I also say that we do. One of the issues that we have is kind of twofold. One, we don't actually have a really solid internal view of the consensus on what block producer hardware is. There's a lot of it out there, a lot of configurations are running. And two, it turns out that for whatever reason, we don't see the same level of peer-to-peer network traffic and abuse that that you were seeing, and that's probably because there are some concerted efforts to attack like the centralized nodes in this, or not the centralized, the nodes closer to the core of this peer net in the public nodes and things like that. And since we don't have the same public-facing notoriety, when we put up a node, we don't attract the same level of issues. So we've been trying to do that, and again, that's another one of those things where if people are willing to share certain configurations with us or give us some help in that regard, we would certainly accept it.
No, I mean,
we end up on the edge of the peer-to-peer network, just like most of the users, and that's a different perspective than the people who are kind of the core of the peer-to-peer network.
Yeah, I mean, I guess I understand the arm's length requirements that from B1, but I guess that what I'm saying is like if there's something that we can do to, like, for example, if you needed a box, if you needed access to a box itself, so that you don't need to play the broken telephone game, we could certainly, as a group, figure out a way to give you a box that is very realistic.
Would there be a way to do some kind of packet capture on one of our full peering node that's inline to our BP, and gather some kind of statistics that could be helpful, like network-wise?
It's possible that we could work out a system where we could use that to simulate the node. I think at this point we are trying to lean a little more heavily on you, the operators, to help us distill some of this knowledge and feed it in. Mostly because when we are not actually the operators of these nodes that are seeing the problems, it's really hard to forensically reconstruct some of these situations. Even with full packet captures and perf dumps and stuff like that, you're playing a little bit of like the TV detective game where you're trying to compose a narrative that fits the scenario that you're being presented evidence of, as opposed to just being able to poke and prod directly. So, I do agree that if we can get, if we had a direct node in that position that we could directly analyze, that would speed things up a little bit. There are certain barriers to that.
What about us sending you some traffic from our load balancer? So we would forward a TCP port, maybe if you refer a few others, and you would get a host traffic, right? A bunch of incoming connections.
Yeah. Let me do some.
Yeah.
Let me ask some questions on our side as to whether or not we can do arrangements like that with and feel comfortable with it. There is a fine line that I'm walking here, and I know it's pretty obvious. But there are some things that I'm trying to not say and to say. So these are all good ideas. Some of them are going to have to kind of be sent through a process internally before we could really say yes or no.
We'll discuss in amongst the BPs and a plan to if you accidentally received some SSH information about how to get to a node that had that was experiencing a problem, don't be surprised.
If I never log in with that SSH information, also don't be surprised.
Gotcha.
No, but actually, sending traffic your way, you wouldn't need to even agree. If we knew the IP address of a node, we could just forward TCP connections there.
Right, but then they would have to acknowledge that they're actually running a node on the
net. I'm not going to say that redirecting your traffic is not like a form of attack on our network.
Yeah, we'll
but
attack
it does
you.
kind of ruin deniability if you public block producer call.
There you go.
So, any other issues that are holding back 1.2 from going mainstream? I mean, people know there's like 67 people here. Can everyone push in their thoughts?
The only reason why I heard not to go was Jem said very cryptically that he found a bug, and he never mentioned anything about it other than that he possibly disclosed it to Block.One, and that's the only reason why I haven't upgraded yet. I'm waiting for a resolution on that or any kind of response back from Jem.
Who has information about that? Or more information?
Exactly my point is that there is no information on that, so I'm not sure how.
Well, there are bugs all the time, right? We know there are bugs, and there's going to be still bugs, so we're going to fix them when they come. No other reason for standing back?
Dafang, on Kylan, I think, I don't know if you remember, but I think a lot of nodes are running 1.2.5 on Kylan, correct?
Yeah. But we're also seeing a lot of transactions being reverted. We don't have a specific stats on like how many transactions get reverted, but it's empirically when you play with using Cleos to buy some RAM, 1 out of 5 times get reverted. We don't have a specific stats yet, so that's what we're trying to get right now.
Is that with the latest patch that does the while loop instead of the if loop?
It has been happening for a while already. So
I think that was resolved in 1.2.4. Bart, correct me if I'm wrong.
We have a good number of nodes that's already on the latest version. We can do a survey and see what everybody's running. Get back to you guys. We don't have a specific stats on how many transactions what's the percentage of transactions get reverted, what's the view of all the versions that's running. So
what do you mean reverted?
So you see a transaction that got sent, and then 30 seconds or sometime later, you keep on querying that transaction ID, and then 30 seconds later, you won't be able to find that transaction ID anymore.
When you query the history API, or you're querying the result of the transaction?
We're querying the history API.
And it disappears from that, so it sort of forks off. The only way
it's not forking off. It's being run locally on the local node. The local node does like it assumes that the transaction will be included in the block.
Speculatively, is that what you mean?
What?
Speculative application of transaction?
Right, exactly. And then it's never actually included in the block, so it disappears 30 seconds later.
So, 30 seconds? Or just half a second later?
For
like 30 seconds.
Yeah, around 30 seconds.
Bart, the algorithm for speculative is undone immediately if you have a block, or is it just applied also on top?
So there are
applied on top.
2 versions of speculative execution at this point. If you have received the transaction over the HTTP RPC, so you are the first recipient.
Right.
We consider that a persistent transaction for that node, which means that as new blocks come in, you will attempt to replay the side effects of that transaction on your node so that to your RPC users, it tries to represent the best speculative state possible until such time as it's figured out that transaction won't ever make it because it expired, it hasn't appeared in a block. For peer-to-peer relay nodes, the transactions you learn over the peer-to-peer network, those instantly forget it. So they'll play it onto their current speculative block. When a new block comes in, they won't bother reapplying any of those transactions because they were just using that as a way of doing a fast filter to see if it was a valid transaction so they could forward it along on the peer-to-peer network. So they don't have any need to persist that state over and above just the relay. So those are the 2 kind of modes we're in. I'm suspecting that since you're hitting an API node, you're probably hitting the same API node that you submitted it to, which in that case it would be considered a persistent transaction for that node. So it's likely that what this symptom represents is a transaction hits that node, it's reflected on that node in that node's state in the history plugin, things like that, up until the time that it expires, at which point, if it hasn't made it into a block, it would suddenly appear reverted because it would disappear from those RPC queries. But what that means is the problem is that even though it got received by the HTTP RPC node and processed, it's not actually getting through the entirety of the peer-to-peer network and into a block. So some failure in that chain of events, getting all the way to a block signing node, being put into a block, and having that block propagate back out and being accepted by the network is failing in that case. Ideally, in the case of like micro forking that we've been seeing under load, that shouldn't be a situation where we drop transactions. Really, it shouldn't be a situation where we drop transactions in the nominal case because the transactions that were in the micro fork should appear somewhere in a different block, as long as the other block producers were also aware of that transaction. Now, obviously, right now there's a gap between what the intended behavior is and what the actual behavior is, because as we're observing on many testnets and probably on mainnet, we have a network that should have enough capacity to accept this transaction. A peer-to-peer network that doesn't appear to be partitioned in any specific way. So you would expect full knowledge of that transaction to be achieved before it expires, and there's enough space in the block to include those transactions. Figuring out where in this deep pipeline of events that transaction is being dropped on the floor is where things get difficult, because there's a lot of hands that it touches, a lot of nodes that it would touch. Each node has some ability to drop it on the floor if they think that it's bad for CPU reasons or otherwise. They just wouldn't relay it, but then you would expect a different peer-to-peer node to pick up the torch and relay it. In an overly connected peer-to-peer network, you would expect that as long as any one path to the producer survives the transaction, that it would get there. And so figuring out how it's failing all the possible paths to the producer, or why the producers each in turn in that 30-second period are choosing to ignore it, is the question. And figuring that out, some of that's going to be we want to give you guys some features in the next release that will allow you to, if you so choose, verbosely log some of these decisions that your node is rendering on certain transactions, so that as a group you can come together, aggregate logs, and try to determine if it's one of your nodes that's dropping. Until you get a certain percentage of nodes coverage in that system, there's a lot of dark corners that you can't see, and if a transaction gets dropped while it's in the dark, you wouldn't necessarily know why. But as cooperation on that regard becomes more pervasive, you should be able to get a better view of how transactions are proceeding through the network, and also when they are being dropped from the network and why, which would lead us either to a better understanding. Maybe these are all transactions that are happening pretty close to a CPU limit, and so subjectively speaking, the peer-to-peer nodes end up thinking that they're going to go over, and so they by and large reject them. Or it could be a bug, where we've got something about propagation on the network that's preventing them from doing it properly. There's a lot of variables, and until we get some good coverage on them, I'm not sure we're going to be able to really trim down the possibilities for why those things are happening.
Yeah, if the logging is better, then yes, we can try to aggregate all the logs from the testnet and have a clearer view.
Do we have a bisection of that? Daphne, do we know if it was introduced, if we started observing that after a given version?
Not really.
Okay.
Is it a specific application that you can reproduce this on? Like, is there a test, like a test harness that you can share that we can test it and help try to debug it for me?
Sure. We found this problem being very problematic when we were developing a game, and that game we sent a bunch of transactions, and we saw the transaction getting reverted. So we started debugging this more. I can write down a test case, and basically steps that can reproduce this maybe 1 out of 5 times, and I can send it to you guys.
Yeah, that would be great. So the because that kind of thing. I mean, we're quite heavily focused on trying to encourage dApp development at the moment, and the API node stability in conjunction with that, like really hurts the developer experience.
So people who are developing on Kylin testnet, there's a lot of developers that's currently developing on Kylin testnet, and they complain to our Telegram channels all the time, like, why is my transaction getting reverted? They bought some RAM, and then a few seconds later, the RAM is gone.
Right. I mean,
it happened to me today, just now, just 10-15 minutes ago.
Yeah, I'm not sure, and I hope I'm not kind of forking this conversation too much by asking this question at the moment. But we seem to be having a hell of a time maintaining a reasonable latency on our HTTP endpoint at the moment. For whatever reason, I haven't managed to narrow it down to if it's a specific type of HTTP request or just pure load, or we're still narrowing it down. But it seems that no matter how many boxes I put behind this HTTP node, someone manages to thrash the thing enough that the response time is up in the multiple second range. It's even after restarting it just seems like the HTTP performance seems to degrade to a degree that as a developer calling the API endpoint, I know I wouldn't be happy with the performance.
Is it a steady decrease?
Sorry, what's that?
Is it a steady decrease or increase in time?
No, it seems to be load based at this point. So like we'll see at specific times of the day, like it's normally Eastern time, midnight, of course, just as I'm trying to go to sleep, that the thing will load. We'll seem to experience it. But
DDoS attack pretty recently, and you can take this offline later. I might be able to point out someone might be attacking your system. I'll tell you which request to drop.
Okay, yeah, that would be great. Another thing that we've considered talking about is essentially creating the idea of premium API nodes, or something that would require an API key of sorts, so that you have vetted traffic to certain API endpoints. Although the open network is great for everyone to hammer, I think as an ecosystem, we may want to consider how we offer developers, reliable nodes that aren't being hammered by just random endpoints, if you know what I mean.
Do you also have requests per second, for example, statistics?
Yeah, we do, and it's not that high. We're seeing, normally between 250 to 500 requests a second.
Because we're doing 2,500 to 3,000 and not having any issues.
Yeah, that's what seems strange. Well, I know you're on bare metal, and those boxes are certainly performing better based on the last round of stats we did with you. But it just seems like there must be a specific transaction. So I'll take it offline with you if that's the case. But
I think I might be able to help based on my experiences.
I could join in on that call if possible.
Yeah, I suspect that I'm not the only one suffering from this, but I'll just be the one that puts my hand up and say, yeah, I know we're all getting abused somehow. So maybe we should make that a separate conversation.
I have a question, maybe. So I've been working on some endpoint to make push transaction more blocking until something is in a block or something is irreversible. What do you guys think of that? Like, I was proposing to have push transaction. Actually, we shipped it. We have an endpoint on Kylin that does that, where you point your EOS.js, and when you push transaction, it blocks. It doesn't return right away. until it's put in the block. Like for example, these things, Dafung, they wouldn't be speculatively. They wouldn't be in a block, so even though they're speculatively executed, it wouldn't return. It would eventually fail after X minutes. So you'd know you're trying to restart.
I think this is very, very important for dApp developers that are developing on like light clients, like web client, because otherwise, like with the game that we're developing, we will have to, have some logic that constantly checks for the transaction getting into the leap, and it was very, very bothering. And because the user, once they play the game, they could have just turn off the browser and thinking that the transactions that will get sent, because that was promised, right? It was promised that every 500 milliseconds there will be a block, and they thought their transactions already get included into the block. So something that can guarantee them that this thing will be sent, will be included in the block, I think will vastly improve the user experience. So they don't have to deal with things get reverted and they have to retry. And dApp developers writing all the code to do that for every other dApp, that's insane.
Right. So that little system there has two levels of guarantee. One is just it will return the block ID in which the transaction is added to the traces that are normally returned by push transaction. It also has another way. It goes to irreversibility. So it's going to wait for 3 minutes, 4 minutes, whatever, and then return once it's reversible with the original traces, which can be a little bit different, but and that's going to be that's a little piece of software we I don't know, maybe we can send over and people could adopt. I think it makes sense for that to be an external system rather than something built in Node EOS, because it's checking Node EOS. Right? It's a long-running connection. You want to have maybe all of those. I don't know what you guys think of that. Is that something many VPs could adopt?
It sounds to me like this can be done client-side, though.
So it's not easy to do that client-side because you need to handle the forks. You need basically, so we're connecting to the peer-to-peer network, and we're looking for blocks that are flowing, and we're also handling the forks off-chain, right? Out of the node.
To handle the forks, just use an endpoint that traces the last reversible block rather than the head.
Right. So the client will need to poll, and then what? It needs to have a history API block that last reversible block, and you're going to poke that. It's going to be harder. I prefer putting that on the server side, but anyway.
Have you seen the Watcher plugin yet? It basically
yes. The Rosehan?
Yeah. What if you use something like that? Because like the zero, and if you use the 0MQ plugin, if you kind of combine them. 0MQ can block Node EOS, and that way you can guarantee that you only process the blocks as they come through.
I don't think we're talking about the same thing. The thing is, a client running JavaScript is going to be blocked in his push transaction call. So it's the RPC endpoint we're blocking, not something internal. The client does not have any HTTP endpoint for you to call, right, with the Watcher plugin, which just does.
It goes the other way around. It pushes to your client.
But the Watcher plugin doesn't push to your client.
It does. It pushes to the client.
Yeah. So if you use that with like 0MQ will push to the client with it.
Okay, we could take that. I just wanted to throw that out.
I agree with you though, Alex, in that the less the app developer has to think about it, the better. This is a new paradigm, and there's enough complexity trying to introduce developers to it to begin with. So the more complexity that we can move to the server side and abstract away from them, the better, in my opinion.
Yeah.
Well,
I think
we have some. Sorry, go ahead.
Just said, I think if we combine the watching plugins, say for example, there's an EOS authority endpoint that runs a watching plugin. They could submit the transactions there, and we could run the watching plugin, which goes back to them when we get the lib. So we can confirm either the lib or the block. It has to be a specific endpoint that supports this, really.
Right. So, the thing is to having the little magic that blocks the RPC call until these things happen. Now the backend can be implemented many ways, but the design I'm talking about is mostly like having a push transaction endpoint that has that behavior, however it's implemented back in the backend.
Yeah, how long can the RPC wait really? All the
An
time?
HTTP connection, you can keep it open for. Usually, it will be more and more risky if you go over.
So that's where 0MQ is nice because it's going to push it onto a queue and it's going to block until, if you use the push pull with it, it's going to block until that work has been pulled off the queue.
And you'll expect clients to have a 0MQ implementation?
No, you would have to have something between there. But the point is, you take, I mean, there's a risk, right? If you use HTTP plugin, the big risk I found was if you replay Node.js, it quickly overruns your endpoint with HTTP requests, and those requests are dropped and they're gone forever. If you use 0MQ, you know, it's gonna block Node.js until that work is pulled. So it can only, basically, you're not gonna lose any messages, right? So that kind of gives you that in-between point to queue things up and make sure that you don't ever lose those blocks. I'll send you what I was working on here.
Guys, I don't know if it's the right time to bring this in the conversation, but now that we have all this group of people in front of us, and we've been running the actual mainnet for some time, and it's working, and we have also Bart from Block.One on the line. One thing that as a BP, and we had to kind of rush to bootstrap the mainnet. Now it's working. One thing that was missing, and that now would start to really make sense to sit down and think that through as a community, along with Block.One, is give us some insights into or think together what is the best way to peer this P2P of the core of the network, the BP meshing, like how to best optimize it so that the top 30 or more is best meshed like globally in terms of optimization, because the schedule now is very simple, and we're kind of sometimes the schedule, like, because it's alphabetic, jumps literally from the worst amount of physical distance, and sometimes it hits us. But at least if in terms of peering optimization we could do that now, it would possibly help to have the packets flow better around the planet.
My personal opinion is choose like something like Dragonfly or Taurus routing. Pick producers deeper into your schedule and don't put on like 1,000 peers on each node, because you really only need a couple, and then all these peer-to-peer problems will go away.
Say that again, Taurus routing?
Yeah, Hypercube, Taurus, Dragonfly, there's plenty of different styles that you can go for interconnecting things together. Really, the easiest one is just pick the peer in front and behind you in the schedule, then +1, and then +2, and then +4, and then +8, and then peer to those guys. And if everyone does that, you'll have optimal routing.
Yes, no, that's sort of the idea that we're going after at the moment, but it's not systematic, and there's no way for us as the part of the top 21 to know if our neighbors, our colleagues, if you will, are doing something similar, and if it's optimal, like, because if A is connected to B, like bidirectionally, the Node OS will essentially keep only one. Like it's if A connects to B and B connects to A, it's gonna end up just keeping one. But still, there's like globally, it's very hard for us in isolation to know what the peering configuration of the others is at any one point. There's simply, and maybe we need something on-chain, like a way for each BPs, like top 21, top 30, to publish their sort of outbound peering. I'm not sure. Maybe there's some people might be sensitive to having that published in plain text. I'm not sure, but maybe there's another way to do that. But we need at some point, because on the quote-unquote normal internet, they've solved that with BGP and all that, and it's been optimized over 40 some years
and they've managed to come to have sort of tiering agreements and things like that. I'm not saying that that's what we need here, but at least we need to start as a community to think through those problems and not just have each BP work in silo and kind of hope for the best.
One of the ways that we can start doing this, at least, is inviting the Chinese block producers on this call and perhaps pausing every couple of minutes to give a translation for them, because I don't see many on right now.
I think there are a lot of Chinese PPs here.
I have a question regarding that, Bart. There is a location flag in the reg producer, and as I looked, the schedule is created by the system contract. Why don't we shuffle by the location? That would be a small update to the system contract, and then we could work out together which position in that UN 16 we want to be in, and just go in between others that we know are close and drag a big map. We can do that on an app.
Is this the same thing we proposed a few months back?
I don't know, maybe. But the thing is, the solution is at hand. It's very simple. Bart, could we do that?
Well, there's two problems being discussed right now. One would be what you're asking about, which is the schedule at block producers taking turns. And yeah, that's completely in the domain of the system contract, because no matter how you sort that list, there is some political concerns with it, concerns of fairness, concerns of anything. Block.One is staying mostly hands-off on that. So if the community wants to suggest issues on GitHub, rally support, and make it pretty obvious that it's a relatively neutral change for us to implement, we might consider it. I would also, at this point, take the option to note that we are producing what we consider to be a reference contract for the system. And the community can always take it and fork it and apply whatever the communities think is the best governance for their independent chains, whether it's a test net or this network or any side chain or fork in the future. So the answer of is this possible is yes. Past that, it gets a little more complicated. But that's only one of the problems we're talking about, is simply the order in which we produce. The second is just general peer-to-peer network structure and how things propagate across that network, regardless of who produced the block. And that's a different level of problem. So I think we need to be clear about which one we're talking about at one time. It would be nice if we could say, well, there's an idealized form of the peer-to-peer network that solves all these issues, because even if the block producers aren't in a certain order, it's all low latency. Until we have some sort of technical proof of that, I consider that to be like a theoretical fix. And we can also pursue that. Shifting the peer-to-peer network would also be something that would have to be done with lots of coordination with the community, since, or at least providing bridges to the old peer-to-peer networks, since a lot of users and customers have the old peer-to-peer network as their de facto standard. So we can talk about those things.
BNet now? BNet versus P2P?
BNet's architecture, like it's how do you want to call it? It's the overall structure of a peer-to-peer network on BNet is no different than the overall structure of a peer-to-peer net on the regular net plugin, from like a who connects to who and how. It's still static assigned peers. It has different operational protocol and different semantics, therefore, but from like a topological level, that was the word I was looking for. It's identical.
Can you confirm my hypothesis that, or based on what I could read, BNet performance or like CPU usage profile might be better because it's multi-threaded, so it would have less chance to clog any one node because it would better use the threading?
Because you put maybe in that sentence, I am inclined to agree. So BNet is threaded at a connection level, so that each independent socket is being handled by a different thread. But that doesn't paint the whole picture of what causes load and congestion for networking in an application like this. So yes, it has some characteristics that perform better under certain types of load. There is also complexity introduced by that threading, which means that there is a certain type of load where VNet actually performs worse. And because of reasons like that, and because of complexity of threading, that's why, for the most part, the VNet plugin is still kind of in a prototype and experimental phase. It's proving to be more difficult to get stabilized and as correct as the original peer-to-peer net plugin. Not trying to say that that has no bugs in it, just saying that, you know, pound for pound, it's more difficult to analyze the inner workings and complexities of VNet than it is the peer-to-peer net plugin.
So far,
and again,
go ahead.
And again, that only addresses like the on-node characteristics of the peer-to-peer networking and none of the topological concerns.
Mm-hmm. Yeah. As far as I know, and that's the case for us, the mainnet isn't using much VNet, like even experimentally, like between BPs. What I saw so far is just everybody's just exposing a legacy, well, you call it the standard, the P2P on public endpoints. We haven't even tested it much at large scale, so we don't want to rely on it. But
VNet at large scale, we got seg faults every single hour, and so we quit that real fast.
Oh yeah, and you that was in June, or?
Yeah, it was a while ago, and I think that's been fixed by now. But that just, you know, when you get that slap on the wrist, and now you set up something else, you stick with that.
Yeah, no, I understood. So if we're gonna stick with that, like medium, long, at least medium term, short medium term, we'd better, as I said, like start to work together. Like, and this call is not the time to discuss the details of that, but I'm just kind of calling out the community to kind of form maybe a working group that's interested in optimizing this meshing and discuss possibly the schedule optimization and all that. But it's something that I see we're gonna need to do if we want to better, like, to maximize the throughput of what is promised by EOS.
Yeah, okay. I think some of you know that I have been working on this since before launch. So I hope when I get Hyperion ready to collect logs from everyone, we'll be ready to optimize the schedule in a multi-sig propose. So we would have no governance issue in between. So we just propose a new schedule order, and then the elected BPs will accept it or not.
Well, what's the design of that? You want to modify the system contract to have an algorithm, or to?
No algorithm in the system contract. We can do the algorithm from outside, and the contract will just accept the new order of the elected BPs.
And so who would set the order? External systems would set the order?
Would propose the new order, and then the BPs would accept that or not.
You have a prototype of that? Seems a little fuzzy to put in the system contract.
What? For the system contract to accept the proposal?
Well, it's just that, because the schedule can change according to votes which are not under our control, and we can't wait for a multi-sig to happen to set a schedule, right? It's too fast. It needs to be algorithmic. That's my understanding, at least.
Yeah, I know, but for a prototype, it's better to do it off-chain, and then if we can get the algorithm ready, stable enough, we could do in a contract, but I don't know.
I think there was another thing we wanted to talk. It's ending close to the greylisting. If there's ethics of it, what's holding it back, and do we have more long-term solutions for resource allocation? Can everyone pitch on that?
looks to me like pretty much everyone's applied it by now. So the question that I have is Block.One going to be working on something that's more reasonable to handle the leftover resources, or the relaxed chain state resources, so to speak? Is that something that you guys are working on, or is that something that we're going to have to take the torch with?
So our stance on that right now is that we have internally started to make sure that the algorithm in place matches the intent of the algorithm in place. We're not really looking for, I mean, we've got eyes open for bugs as possible, but it's also very possible because there's some factors in that mathematical equation that have been wobbly over time that we didn't necessarily understand the correlations between those factors and how that would affect the overall performance of the elasticity of it. So we want to analyze and make sure that the math is right so that we can expose some of those cofactors in our first patch that is technically going to be a hard forking change, because it will expose more things to the WebAssembly contracts that have been there. One of those things will be access for system contracts to modify these factors in that system. So if we can find parameters for those equations that work a little better, that keep the users from feeling the road, so to speak, so acutely, then that will be kind of where we want to go with it. Because that mathematical equation is part of consensus right now, it's very difficult for us to change. And it's not likely that that's going to be something that we can offer to put into completely into WebAssembly anytime soon to make it easily upgradable, something easy to experiment with. So right now we're starting with the easy step of exposing the parameters and then putting out some documentation to you, the maintainers of the network, so that you can come to consensus on what those parameters should be. So that's kind of step one. The other thing I would say is that if that fails, we would expect them. If that fails to give the experience to the users that we'd expect from the network, there is a next level of it where if we can get a kind of sub algorithm for balancing underneath that, so it never violates the constraints of the consensus algorithm, but it provides perhaps a different level of allocation of those resources at the same kind of level that Greylisting currently operates at, which is the subjective opinion of the block producers, then that would be something we would entertain getting into, like the producer plugin as a policy thing, so that just like Greylisting, if the producers come to consensus on a different mode of allocation that doesn't violate the chain consensus constraints, they would have a little bit of ability to deploy that and maintain that. And as far as what that would be, there's way too many options to enumerate them right now. The only real requirement would be that, changing the baseline guarantee from chain consensus requires a hard fork. It's a lot harder to change than, say, finding some version of an algorithm that can not violate those constraints, but maybe better allocate the resources before it hits those limits. Does that make sense?
What are the options you're saying? The too many, Bart. What are those things you say there's too many to enumerate? Can you enumerate one or two just to have an idea of your design there?
Well, okay, so we don't have a design. We would be looking for community input as far as like what are good first designs to implement, or how do we get a system in, or the community can be responsible for things like this. But there's when you look at what we're trying to do here is we're basically trying to do fair resource allocation, and there's some that lead towards deadline scheduling of resources, and there's some that lead towards proportional allocation of resources, and there's some that lead towards some sort of stochastic random. Like the debate is what is the best fair representation of staking to resource allocation and on what time frame. And we have, like I said, consensus guarantees that will limit what you can do to some degree. But if underneath that hard limit, there's also plenty of things the producers can do. Greylisting is one form of it. You are basically opting to deny access to the not guaranteed half of the resources or part of the resources to certain accounts, basically on a gray list.
So would all solutions be like rate limiting transactions? Anything that's not on chain would be rate limiting any transaction based on something. Is that what you mean?
Sure. Yeah. I mean, at some point the decision is very, it's just very cut and dry. It's at the point in time when you have space in a block, what do you put there? The chain will deny you if you try to violate the chain consensus rules. After that, it is left up to the subjective opinion of the producer making the block what goes there. And there's plenty of ways where our current system is representative of that. You know, gray listing, black listing, white listing. Those are all just the very baseline level of what I would call producers' policies that affect what that producer is willing to put into a block. And so, in forms of policies, the producers have a lot of control. There's a certain baseline guarantee from the chain, which the community can then hinge on, so that certain dominant parties can't unilaterally control a chain without also unilaterally controlling the stake. But past that, as long as it's a policy that you feel comfortable will, keep you in the good favor of the community, then there should be some avenue for you to deploy some of those policies. We just don't have it yet.
But then there's also the, let's say, legal or arbitration or the Ricardian contract obligation of not front running and not fiddling with incoming transactions, respecting the order there. So at some point it becomes a little bit of an random and arbitrary.
Absolutely, and this is why, for the most part, Block.One has to keep it at arm's length or take a kind of lagging view on it, because it's not. It is as the producers and the maintainers of the network, it's your policy, not our policy. So, because for the most part, like you said, there's obligations that you have as producers to the community, and you need to fulfill those obligations, and so therefore your policy should be part of fulfilling those obligations, not part of some sort of technical limitation.
Right. So what does everyone think on that?
So maybe what we need from Block.One is adding a few more knobs that are optionally, of course, kind of leave those knobs to be the current default, and have block producers some kind of EOS fraud ability to kind of in the system contract set those knobs with different variables that affect that algorithm, like in terms of queuing. So that's you're not putting your finger into the politics of it, but if we had those knobs to play with on a testnet, then we could stress test it and see what's best combined with the politics and all that.
For the most part, I agree. There's a difference. There's two types of knobs we can offer you. One is a knob with consensus behind it, and that's one of the things we were planning on exposing. Is basically the tweakable knobs for the current chain level algorithm that we have right now. Because of all the other considerations, that chain level algorithm has to be very basic, and it also can't really be something that's deployed at the moment of truth when you have to decide, does this transaction go into the block, or does it get deferred, or does it get dropped? That's just because of the split between what is consensus on this chain and what is, basically stake-weighted voting on the main net. What should be part of that? So the second type of knob we can give you is much like any kind of contract-based communication of blacklisting and whitelisting. Like there's a decentralized objective commitment that this is what block producers should be doing, and it is up to block producers, perhaps via software that Block.One enables, to implement those policies. But there would be no hard link, no hard guarantee that block producers are following those things, because those things are not enforced by the consensus of the actual underlying blockchain. They are they are enforced at a higher level. Does the distinction there make sense?
It does. So I wanted to gather the feedback from the community that's gathered here about those things. So we have a high bandwidth communication. What do people think about doing that and applying some more gray listing, like, control of transaction throughput? "67 people here."
Something I think is basically we just need to move away from first come, first served, which is the real problem here, is because Twitter is always first come because they're not trying to do anything else other than be first come. And everyone else who's trying to use the leftover resources is doing something like pushing one transaction and waiting for that result, whereas Twitter just doesn't care. They're just going to throw out transactions and whichever one goes in, goes in. And so something like exponential backoff per user, or at least recently used, or some additional policy that can still go on top of it and respect the current chain consensus rules sounds possible to me.
Also a per account, so rate limiting, you would, oh yeah, that's interesting. LRU. Any other opinion there? That's interesting.
Yeah, I like that idea. Specifically like some kind of back-off algorithm or something like that. I think the conversation is tangled up between politics and the technical aspects of it, right? So there's the idea of how you handle the situation has some kind of kind of political aspect to it. So when it comes to a group of purely technical people, I think it's not that people don't have opinions. I think everyone is kind of like, there's a technical way to handle it, and then there's like there's an uncertainty as to what the correct political way to handle it is.
But the end goal is always servicing the users as best as we can, right?
Yeah, absolutely.
And we're seeing some abuse in one sense, and the algorithm should try maybe to tone down a little bit those abuse, but leaving other users happy. Politics, technical, is to serve the users, right? That's the end goal.
Yeah, absolutely. So so I think the suggestion that was just made there sounds like a good option to me, which is there should be some way of applying an algorithm on top of what's currently happening, so that we can scale back. Like basically, to your point is that if you're consuming all of the extra resources for X period of time, then you have a factor applied to that, and it's almost like a scale back algorithm. So you can spike into that position, but if you consistently do it, it scales you back.
Is anyone in this channel opposed to having some things like that?
Well, these kind of issues have been happening for years in networking. Frame relay has got I know frame relay is quite old, right? But it's got something called like a commission, like a certified information rate that you can have, and it allows you to burst on your segment. When I say segment, I mean on your amount of kilobits per second that you can have, only to a certain amount. Now, I think one of the main issues that we've got is that there isn't like a straight line across how much resources are actually available in the network, where some producers have some more threshold, others are slightly lower. The idea is that you should always be allowed to burst, but maybe not burst way above what your committed information rate actually is. So there should be a threshold based on how much you have at stake, and from that you're allowed to burst into the available bandwidth, or in this case CPU, that's actually available. So these kind of things have been happening for years. It's always been an unused bandwidth on a network, unused CPU, etc. And you don't want it to go to waste, because that was the whole thing Dan was talking about. You don't want people to just waste it. It's not being used, so let everybody use it. I think we need a mechanism to at least be able to maybe from your stake give you a threshold to burst above what you are guaranteed, something like that.
So the baseline chain consensus algorithm is already that's the intent of the algorithm already. I think one of the things we're seeing is that it's a little over-tuned. The way the algorithm currently works, because we have a semi-stateless version of scheduling, you get a transaction and you have to decide, only given the state that led up to it and knowing nothing else about the rest of the transaction pool, do you accept or deny this transaction? So the way the algorithm is currently working is that we have what effectively turns out to be like a little price predictor about what it costs in terms of block space in order to get a certain amount of resources onto that block. And so when something comes through and puts a high load on it, it ends up running the price up on that to the point where when it has to make a decision, it's saying, I don't want to take the transaction from this user, their stake is too low, and I assume, because my price predictor is telling me this, someone's going to come with more stake at the very next transaction. And then it never happens because someone like Block Twitter has exhausted their stake and they're in kind of an idle state. But the chain level is so naive that it's saying, all right, I can't take yours right now because it's coming. I just know it's coming. Someone's going to give me a transaction that's better. And then it just never comes. And so it's denied a whole bunch of transactions that it could have made in until it gets to the point where it just cuts out the block because the block is done. I think part of that is over-tuning of the algorithm. In that, like, some of these things are reacting too sharply to load. And if it was actually a better price predictor, so to speak, that's a metaphor, of what those bytes and CPU cycles in the block actually cost, we would see a more ideal thing where they are able to consume a certain amount of load and then other people are able to get in. So there's a part of me that wants to think that exposing the parameters will give you more like the behavior that you're expecting right there that you were just talking about. Whether or not that would be a complete solution, not really sure, because we are still talking about a situation where we have limited resources and we have some people that have a stake of 1/1,000,000% of the staked EOS and are still expecting to transact on the network pretty regularly, whereas someone who has staked a lot more, tens to hundreds of thousands of times more, is currently dominating the network. And there's some macroeconomics in play there where it might just be that the floor of stake cost on the network is too high because of the load on the network. Right now, just looking at the numbers, it doesn't look that way, which is why I'm tending to think that this is something where we've overtuned the algorithm. But there is a version of this network where everything looks like all the blocks are full and the floor to play will just be too high for the average user if everyone else is willing to pay more.
But another factor that could be added in here, since it is the account holders that we are eventually servicing, being able to look at the number of destination accounts, for example, that are in play. So in other words, if the contract that is trying to spike is interacting with the majority of the users on the network, meaning that the majority of the users are interested in using this thing, then it can be given preference in some way. I'm just trying to think about another factor is, does everybody on the network want it to spike? Is the question.
Sure, and this is actually exactly why I say that the chain level, the consensus level algorithm has to be very simple, because when you say, do the people on the network want this to spike, my mind instantly goes to, how do you know it's an individual versus a sock bucket proxy for someone? So our solution to that in the chain is that things are weighted by stake, and so we kind of skirt that problem, creating a different problem, admittedly. But anything that would depend on some sort of judgment call as to whether or not this load is affecting a majority of the users, where users are considered to be individual humans or applications or whatever, those are things that I don't feel like we currently feel like we can solve accurately at the chain level and consensus, which is why I would say those would end up in some sort of policy level, where if you, as a subjective judge of does this affect more or wrong, then the community can can have that feedback loop with you, as opposed to if we put it at a chain level where it might, not be something the community can really have that feedback for.
Yeah.
Well,
one thing that's happening now is that we're kind of putting all, as you said, like the concept of a user of the network and the concept of is it an end user, like an actual human, or is it a headless piece of code running in parallel and all that, just trying to game the system? There's no distinction, and yeah, that there we come in. Then I go into the contentious part, the politics. We need a way maybe and to distinguish those two, but that's very contentious. It's like effectively like mark certain accounts or as sort of I don't know, like it's. I don't have the answer, but that's definitely the crux of the problem. Is that there's no way to distinguish those two.
KYC, everyone wants that on EOS, right?
I think
yeah.
The network needs to be resilient no matter what's thrown at it. Otherwise, you're going to be back and molding the whole time.
Right. But I actually, Bart, I also did want to thank you for the quick turnaround on the patch yesterday. Although we haven't entirely resolved it, I recognize that it's a bit of a thankless job with all of us complaining about the stuff 24/7. So I appreciate it.
I appreciate you saying that. One of the more frustrating aspects of my job is that sometimes we just don't know, and so once we get a good beat on information and people are providing us information, we're usually pretty excited to fix it because it's one of the times in our job where we get to feel like we're directly contributing to the success of things in a very visceral way. So if we can speed up the discovery and the way that information flows, I think you would find that we could be a lot more responsive on several of these issues. Just having the awareness is kind of the first step.
Right.
All right, guys. We're coming up in about 75 minutes on the call. I think it's about time to end it. I think we have a couple of working groups. Looks like that could spawn off what we've discussed today. Probably within a week or two, we should probably look at organizing some more calls like this, seeing what those working groups come up with. I just want to thank everyone for joining today. Any last things that someone thought needed to be said before we jump off? Awesome.
Thank you for organizing this, Josh.
No problem. Thank you, everyone, for coming.
Had a baby. Bye.